Hello, this is William from Visual Components. In this video, I'm going to show you how to attach a sensor to a conveyor and then connect signals in that sensor to a robot. To get started, go ahead and clear the 3D world of all components. I'll now go to the eCatalog panel, and let's use a feeder and a conveyor for this example. So under Models by Type, I'll expand feeders, click Visual Components, and then add a basic feeder to the 3D world. Let's now change the width of this feeder. So in the Component Properties panel, I'll set conveyor width to 200. Let's now add and connect a conveyor to this interface shown on the feeder. So under Models by Type, I'll expand conveyors, click Visual Components, and we want to use a simple conveyor that does not have a built-in sensor. So I'll use this item here called conveyor and drag it into the 3D world, and I'll use the PMP command to plug the conveyor into the feeder. Let's now change the type of this conveyor. So in the Component Properties panel, I'll set conveyor type to belt conveyor. Let's now add and connect a sensor to this conveyor and attach it to its path. So in the eCatalog panel, I will first collapse conveyors and feeders, and then click this Processor Smart Collection listed under Models by Type. So this automatically collects all the components that are modeled as external sensors, and you can use these components that are listed here as templates or examples for modeling your own sensors. In this case, we want to use a simple example, so I'll use this conveyor sensor item. I'll drag it into the 3D world. And by default, most external sensors are modeled with a special type of interface that allows you to connect a component to another component and attach that sensor to a path in that other component. So right now I have the sensor selected and the PMP command is active. So I can now direct the sensor toward the conveyor. And notice I get that green arrow. So this lets me know I can plug this sensor into the conveyor. And if I move it close enough, the sensor now connects to the conveyor and attaches itself to the path in this conveyor, which you can see indicated here by this blue arrow. Now, this is not an internal sensor in the conveyor, it's an external sensor which is connected to its path. And that also allows me to move the sensor to a different distance on its connected path. So notice I can now drag the sensor, it's still connected to the conveyor, but it's just at a different distance on its path. So I can actually move the sensor right there. And to see how this all works underneath the hood of the components, if you have access to the Modeling tab, I'll go there now. And I do have this sensor selected. I'll now show its behaviors. And we can see here it has a path interface, and this is a one-to-one type interface, which makes sense because you want the sensor to be connected to one conveyor, not multiple conveyors or multiple paths. So let's actually look at these properties. Expand its section. Notice it has a processor field, and this works with component path sensor behaviors. And right now it's set its sensor property to component path sensor, so that's referencing a sensor in this component. And its parent property, its checkbox, is not selected. So this means this component will be attached as a child component to a path. And to see how that works, let's actually select the conveyor and then show its behaviors in the component graph panel. You can see here it has a process interface, and this is a one-to-many type interface, so this actually is allowing multiple sensors to be attached to this conveyor's path. And let's actually see how those properties look. So I'll expand the section. It has a processor field. And notice it's now referencing a path in the component, and the parent property, its checkbox, is selected. So this actually is allowing multiple sensors or sensor components to be attached to this path. So if I actually select the path here in the component graph panel, and we go to its properties, notice it does not have any internal sensors listed here, but it has external sensors, which is found from this sensor I have attached to the conveyor, the component. So to see how this works, let's go ahead and attach another sensor to this conveyor since it's using a one-to-many type interface. So I'll go back to the Home tab and add another conveyor sensor to the 3D world. Use the PMP command, and I've now connected and attached that sensor to the path, which now has two external sensors. So let's actually move the second sensor over here at the end. And if I go back to the Modeling tab, select the conveyor, let's actually look at the path again. And in its properties, you can see, yep, it has two external sensors. So if I expand that, you can see there they are. Now, the second part of this video is concerned with connecting the signals in these sensors to a robot so you can use them in your simulation. So let's actually get back to that. I'll go to the Home tab, and let's add a robot. So in the eCatalog panel, under Models by Type, let's expand robots. And here are the robot manufacturers we support. Let's now click Visual Components and add a generic articulated robot to the 3D world. So I'll drag that item into my layout and just move it so I can see it, and the robot's within reach. And now to connect the signals in the robot to signals in the sensors, I'll go to the Show group here under the Home tab and select the Signals checkbox. And notice this shows the signal editors of the robot and other components that have compatible signals. In this case, the robot has digital Boolean type signals, and you can see here the components that have compatible signals have this indicator here. It's an unfold button. So if I expand this, the sensor has a sensor Boolean signal, and the other sensor is the same component, so it also has its own signal. Now we want these to be inputs to the robot, so when the sensor is triggered, the robot gets feedback from that. So to connect this first sensor signal, I'll go and point at its red circle, hold down the left mouse button, drag the pointer away to display a wire, and I can now wire that connection to the in of the robot. The green check mark means I can connect this signal here, so I let go of the left mouse button, and now this signal is mapped to this signal in the robot. Now I don't want the signal to be mapped to the 0 signal in the robot, so I'll click this button here to edit that connection. And let's now change the signal to be connected to signal 50 in the robot, because by default signals 1 through 48 in the robot are mapped to perform predefined actions such as grasp and release. So with signal 50 selected here, I'll then click change. Notice the sensor Boolean signal is now mapped to signal 50 in the robot. Let's do this again for this other sensor signal. So I'll drag away from that red circle to display a wire, connect it to the in of the robot. And let's now change this signal to be signal 51. Change that. And now I have a signal in one sensor mapped to signal 50 in the robot, and a signal in another sensor mapped to signal 51. And let's see how this works by teaching the robot a simple program. So I actually want to not show the signal editors anymore. So you can either do this in the Home tab or go to the Program tab and use the jog command to select the robot. And then in the Show group, you notice here you have that same property of signal, so I can just clear that checkbox and the signal editors disappear from the 3D world. And now what do we want to do? Well, let's actually wait for a component to be detected by this sensor and have the robot move over here. So what we first want to do in the main routine is add a wait for binary input statement. And we're listening for port 50 because that sensor signal, that first one's mapped to 50. And we want the input value to be true, so when the component's detected, it will send out a true value, and the robot will wait for that value to be true. Now we're not going to use a wait trigger property here. What this means is the robot waits for a signal event before it evaluates the value at that port or that signal. Sometimes the robot's busy doing other stuff in its program, so it might miss that signal event. So in this case, I'll just have this checkbox cleared. So we'll automatically just evaluate the signal value. So after it evaluates that signal value and it's true, let's move the robot over here. And let's actually teach it just a very simple position, just so it goes over there. And let's make that a point-to-point motion statement. So I'll add that to the main routine. And notice what I'm doing here, it's first waiting for that sensor to be triggered and that signal to be sent, and then it goes to P1. So if I reset, run the simulation, the robot's not doing anything. What's happening? Aha! The component triggered the sensor here, and the robot moved to P1. So let's say we now want the robot to move to another position when this sensor is triggered by a component. So let's reset and do the same thing again. I'll add a wait binary output statement. That's after P1, and we're going to listen for that other sensor signal, which is mapped to port 51 in the robot. We'll set the input value to be true. We won't use a signal event. And let's now go to position 2, which is somewhere over here. Let's add that as a point-to-point motion statement. Reset, and we want the robot to wait. The component's triggered by the sensor, goes to P1, and that same component triggers this sensor, and the robot moves to P2. Let's go and reset the simulation. And in most cases, you want the sensors to do something, or the conveyor that the sensor is attached to do something. So if I actually select the sensor component here, and go back to the Home tab, and go to the Component Properties panel, you can see it has some different settings here. So you can define when the sensor is triggered, and in this case this property is called React On, but it might be named something different. You can see it can be triggered when the leading edge of a component reaches the sensor, so when that first edge touches the sensor you can trigger it, or at its origin, when the component's origin passes over the sensor. And when the sensor is triggered, you can have it do something, so here we have a property called onSensor. Right now it's set to do nothing, but it can stop the part, or it can stop the whole conveyor itself. So what we can do to test this is let's actually set onSensor to be stop part. So we're working with the first sensor. So if I now run the simulation again, it should now stop the part, and yep it does. The robot moves in, another part is created, but nothing happens. This part never moves down to this other sensor. So be very careful when you're modeling a component. Make sure you know what the sensors are supposed to do and whether or not you need to add functionality or logic to your component to turn the path of the conveyor back on and move parts down the line. Alright, this concludes the video. If you have any more questions, please feel free to visit our forum at forum.visualcomponents.com, and I hope you have a wonderful day.